Hello everyone, I hope all of you are doing fine. Today, in this video, we are going to learn force and turning force. This topic is the first chapter of physics, class 10th. Alright, so we'll start with force. Force we have already learned in class 9th, but we'll have a quick revision of it. What is force? Force is an external cause which changes shape, size, direction, velocity, even acceleration, also state of a body. Now we'll understand all these causes with examples. Alright, let us take examples for shape and size. I'll take an example of sponge. If I'm going to apply a force on the sponge, what will happen? The size and shape is going to change. We can take another example of a rubber band or a thread. If I'm going to apply a force on thread or rubber band, what will happen? Obviously, the size and shape is going to change. Let us take example for direction. For direction, let us assume a football is coming rolling towards us. And I kicked it. What will happen? The direction of the ball is going to change by applying force. For velocity, let us assume a person is walking and somebody pushed him. What will happen? The velocity of that person suddenly changes. We can also take an example of a car coming with a speed and suddenly brakes are applied. Then what will happen? The velocity of the car will reduce. Same goes with acceleration. Alright. Let's take an example for state. For example, I have an ice cube and I'm going to apply a frictional force on it. I'm going to rub it. By applying this frictional force, what will happen? The state of ice, which is solid as of now, it's going to change into liquid. So state also changes with force. So force is an external cause which causes a change in a body in form of these. Alright. Now this force can be of two types. First is contact and second it can be non-contact. Alright. Contact force and non-contact force. Contact force. Whenever force is applied between two bodies and the bodies are in physical contact with each other. This is known as contact force. Simple. Example, frictional force, maybe normal force, tensional force. These are the examples of contact force. Let's talk about non-contact force. A force which is applied on two bodies and the bodies are not in contact with each other. This is called non-contact force. For example, gravitational force. If I am going to throw a stone upwards, it is automatically going to come down. There is no string or thread being attached to it so that I can pull it down. No. There is a force which is gravitational force and there is no contact between that stone and the earth. This is known as non-contact force. Examples can be gravitational force, electrostatic force, magnetic force. These are the examples for non-contact forces. Alright. Now, talking about force, the SI unit of force is, it's Newton. It's Newton. Alright, I hope this much is clear to you. Now, a force will move further. A force when applied on two things, like whenever a small force is applied on a non-rigid body, what will happen? A small force I am applying. What will happen? It will result into change in shape and it will result into change in size also. Right? But if I am going to apply a small force on a rigid body, what will happen? Its shape and size is not going to change. shape and size is not going to change. Alright, so this is what we are going to learn. This is what we are going to learn. When a force is applied on a rigid body, what happens? This is what we are going to learn right now. Alright, so there is a force which is applied on a rigid body. When it is applied on a rigid body, it is not going to change its shape, it is not going to change its size, but it will give it a movement. The body is going to move, or this body will create, the body will have a motion. The body is going to move. Alright. Now, this motion can be of two types. This motion is of two types. First, translational motion. Translational motion. What is translational motion? When we apply a force on a body and the body is going to move straight. If I am going to apply a force on a body and this body is going to move straight. For example, I have a big box. I am going to push the box. The box is going to move straight on a straight line. This is known as translational motion. Alright. Now the second motion can be a rotational motion. Now what is rotational motion? When we apply a force and body starts rotating on a fixed axis. The body starts rotating on a fixed axis. This is known as rotational motion. Alright. So we are not going to learn translation motion in this chapter. We are focusing on rotational motion. Alright. And the effect which causes this rotation is called, the effect which causes the rotation is called turning effect. Turning effect of force. See, understand? Whenever we apply a force and the body rotates, this force is called turning force. Alright? And this effect is known as turning effect of force. Alright? This turning effect of force will happen when the body is rigid. Alright? And the second condition, it should be pivoted. It should be pivoted. For example, this is a body and I am going to apply a force here. What will happen? This body is going to move like this. Right? This body is going to move like this. But if I am going to pivot it, if I am going to hinge it, what will happen? This body will give, this force is going to give this body a turning effect. This body is going to move like this. Alright. So, this, for turning effect of force, two things is required. The first thing is the body should be rigid. The second, the body should be pivoted. Alright. And this turning effect of force is measured by a term known as torque. This turning effect of force is measured by torque, also called as moment of force. Moment of force, which is represented by tau. Now, this tau will be equals to, I'll explain this also. I hope this much is clear to you, that whenever a body is rigid and it is pivoted and we apply a force, the body will rotate. It will have a rotational motion because the force is this turning force. Okay. Now tau is equals to force into perpendicular distance. Force into perpendicular distance. Now let us take again that same example. This force this force tau will be equals to the applied force, and the perpendicular distance is the distance between these two. This perpendicular distance is the distance between applied force and the axis of rotation. This is axis of rotation, from the distance between pivoted point and force applied. This is known as perpendicular distance. Alright, so obviously this tau is dependent on two things, force and the perpendicular distance. Alright, now a question may arise, how to get maximum torque? How to get maximum torque? So in order to get maximum torque or tau, what we can do is apply a maximum force and take maximum perpendicular distance. Maximum perpendicular distance. I'll explain the example of a door or doors. Alright, what happened? This hinged part is known as pivoted part over here, and the applied force is on the handle of the door. So whenever we want to move, whenever we want to apply maximum force on it, what we do? We apply maximum torque by applying maximum force over here. And why this handle is attached at the corner? This handle is always attached at the corner, not at the center, not over this side. Why? Because in order to get maximum distance, maximum perpendicular distance, try sometimes applying force over here, somewhere here. It will always be easier to open or close the door if you are going to apply a force at the corner side. Alright, why? Because the distance, the perpendicular distance is maximum. Alright, so in order to get a maximum tau, maximum torque, the force should be maximum and the perpendicular distance can also be maximum. Then only we can get the maximum tau. Now another question may arise, how to get tau 0? Alright, how to get tau 0? So torque can be 0 by three conditions. First, make the force equal to 0. Second, obviously, make the perpendicular distance equal to 0. I hope these two things are clear to you. If we are going to apply a force, the first case, if we are going to apply a force which is 0, that means we are not going to apply any force, then the body is not going to rotate. So we'll have tau as 0. Second, if you are going to make the perpendicular distance 0, that means you are going to apply a force on the pivoted point only. If you are going to apply a force over here only, nothing will happen. It is not going to rotate. Alright. Now third condition. Third condition is when the applied force is perpendicular to the pivoted point. Understand this. This is not same as second. When the applied force is like here, if I am going to apply a force here, so it is the force is the direction of the force is perpendicular to the axis of rotation, or I can say the applied force is perpendicular to the pivoted point. So what will happen if I am going to apply a force here? It is not going to rotate. The body is not going to rotate. So this is how we can get tau as 0. Apply no force, the perpendicular distance should be 0, or the force is perpendicular to the axis of rotation, or we can say it is perpendicular to the pivoted point also. Now, talking about the SI unit of tau, it is force into perpendicular distance, so it is equal to Newton meter. Newton meter is also joule, but we don't prefer this unit. We write tau as Newton meter only. We don't write joule, so avoid it. Right? Newton meter only. Alright? Hope this much is clear to you. Now, tau is a vector quantity. This torque is vector quantity. Alright? So, whenever there is a vector form, whenever there is a vector quantity, it will have a positive direction, it will have a negative direction as well. Alright? So, for this case, if I am going to apply a force and the body is going to move in the anti-clockwise direction, this is considered as positive. And if on a body I am going to apply a force which will result into clockwise rotation, then this is considered as negative. So it is a vector quantity. The anti-clockwise direction is taken as positive, the clockwise rotation is taken as negative. We'll do some logical questions and some numericals of the same topic, and we'll proceed further in this chapter in the next video. Alright, hope this much is clear to you. Thank you.